Hi, everyone, and welcome to episode 4 of Cloud Coffee Break, the series where I help you learn more about serverless and the cloud. So, in these first few episodes, I've been going through the fundamentals of setting up a code project for how I would want to work with it on a team. So, whenever I start a new project, I always want to have a very basic version of the application, what we often call a walking skeleton, deployed to production with all the fundamental technical processes set up. So I'm probably going to be setting up more of these technical processes in what we've been doing here for another few episodes, covering things like development versus production deployment, monitoring, that kind of thing. And at the end of this sequence of episodes, what we should have is a repo that you can use and clone and use as a pretty solid basis for your own serverless work. So this time, I want to start our integration tests. I introduced my thoughts about testing and serverless back in episode 2, and the summary of those thoughts are, well, it's not really particularly different from testing other applications in the cloud. So in episode 2, I went into some detail on unit tests, and this time I'm looking at the opposite end of the testing pyramid. The main point of integration testing is that we want to validate the assumptions that we've made about how we interact or integrate with our technical environment and other services. So typically integration tests take more time to develop and maintain, and they also take longer to run. And so we want to minimize the number of them just to test our environment touchpoints. And we leave the exhaustive testing of our code paths to the faster, cheaper unit and functional tests. My business partner, John Chapin, and I are very vocal proponents of running integration tests for serverless systems against applications deployed to the cloud. And this is where serverless does differ a little bit from traditional development. With serverless applications, a lot of what we do is configure third-party services as part of our own apps, and then string a whole bunch of different services together. Even our Hello World app that we already have so far has two different serverless services. One is API Gateway, and the other is Lambda. Therefore, most of what we want to test with integration testing is our understanding of how all of these services work, and that we've coded correctly to work with them. And so putting our application under test in the cloud makes most sense. Now, some other people disagree with us and think that it makes more sense to use local simulators, things like local stack, for these kinds of integration tests. And the primary reason that they think this way is because of deployment speed. It's a lot faster to deploy locally than remotely, which in turn makes feedback time faster. John and my problem with this is that local simulators do not have the same behavior as the cloud in all instances. And it's not obvious when the local simulators are going to have that same behavior and when they're not. Also, we think that if you're properly separating unit tests from integration tests, then you shouldn't need to run integration tests nearly as frequently anyway, at least not from your own laptop. And so the drawback of slower integration tests against the cloud is somewhat mitigated. I recently wrote an article about this subject of cloud versus simulator testing, since it's definitely not something that people universally agree on. And I give a link to this article in the episode resources. So we test as much as possible with integration tests in a black box approach. And because of this, John and I also often call these types of tests end-to-end tests, which in fact is what we call them in our book that we published mere months ago. Right now, I'm liking the description of integration test a little more, since primarily what I want to test is the integration touch points between services. But I'll probably change my mind back in a few months and start calling them end-to-end tests again. Naming is hard after all. So with this spirit of integration tests in mind, this episode I'm going to be adding an integration test to our coffee store repo. Now, if this is your first time watching Cloud Coffee Break, I've been building an app named Coffee Store, and its GitHub repo is publicly available. And you can see that at Symphonia Cloud/coffee-store on GitHub. There are 3 parts to this week's coding. First, I'm going to write an integration test against our Hello World app. Then I'm going to separate out our unit tests from our integration tests. And finally, I'm going to introspect AWS to automatically get our API gateway URL. So this episode's work assumes that the API has already been manually deployed. And that doesn't work for integration tests being included in CI automation, but we'll be dealing with that in another episode. So first of all, let's write a test. What we want to do here is validate that if we make a call using an HTTPS client to our remote API, that it responds successfully with the expected content. If I were to whiteboard what we want to do here, it would look like this. The test itself is going to run on my laptop, but the application under test is running remotely in AWS. And I'm going to be testing a few things here, like making sure that I configured API Gateway correctly, like making sure that API Gateway and Lambda are correctly configured to talk to each other, that I'm providing a response from my Lambda function that API Gateway can parse, and a few other things besides. All I need to do from my test, though, is make an HTTPS GET request, wait for a response, and then validate that response. So here's the first stab of a test. We create a new JavaScript file using the testing framework Jest, the same one that we use for our unit tests, and that's at tests/integration/api-integration.test.js. First, we define the location of our API endpoint. Now, don't worry for now that this is hard-coded. We're going to be fixing that very soon. Next, we make a call to that API endpoint via HTTPS using a small utility function. And finally, we validate the response. Now let's run the test in exactly the same way that we did before by calling npm test. As expected, this test fails since we changed the message in the test to reflect something that's not yet deployed. If you see here, our test was expecting the message back, Hello World episode 4, when what it actually got back from the remote server was Hello World episode 2, the previous version of our application. Again, I like to have a new test fail if I can before it passes. So now we update our application code to give the right message, and then we can deploy our application exactly as we've done before using SAM deploy. Because we changed the application code, we also need to change our unit test. And now both of our tests pass. Our integration test is successfully calling the application deployed in AWS from my laptop, and everything I want the application to do is happening correctly. Before we commit this code to source control, though, I want to remove that hard-coded URL that we had. I can replace it in the integration test with an environment variable. Now, we're going to be doing better than this in a few minutes' time, but this is the simplest thing that allows us to commit our change. So if we run this test now, it fails as expected since our environment variable containing the coffee store endpoint hasn't yet been defined. And a simple way to solve this is just to set the environment variable immediately before calling the test just from the command line. Now again, we'll be improving this in a moment, but this at least is better than a hard-coded URL. And since we removed that URL, we can now commit our change and push that to GitHub. So last time we set up continuous integration automation with CodeBuild, and so this push to GitHub caused CodeBuild to run. And this build fails because the CodeBuild environment is not setting that API endpoint environment variable. So what do we do about that? Well, in theory, we could configure CodeBuild to use my development version of the application and set that environment variable in the CodeBuild environment. But that's not a particularly clean continuous integration test. Really what we want for integration tests is a completely separate deployed version. Now, I'm going to be setting that up next time, but for now, a simple solution is to only run the unit tests in CodeBuild. And to do that, we need a way of separately running unit tests from integration tests. Now, to separate out the unit test and integration tests requires some Jest configuration changes. So we go to our package.json, and first of all, we introduce separate unit and integration test scripts. But we also have this convenience method called test, the one we had before, which runs both of these two separate scripts. These separate scripts point to different new Jest configuration files, and so we need to go and create those Jest configuration files. First is the unit tests config. What we want to do is tell Jest that when we run unit tests, we just want to run the tests in the directory named unit. The integration test configuration is almost identical, at least for now. It just points to a different directory. Now we can run our unit tests by running npm run unit test. Note that we have to add that run there since unit test isn't a standard npm script target. And if you see here, we're only now running one of our tests, our unit tests. We can also run our integration test, specifying the API endpoint environment variable, just as we did before, and again using this new integration test script. And here we run the same npm test command that we did before with the environment variable, and this still works as well, running both tests. So everything is now running correctly locally, but the whole point of this task was to have CodeBuild only run the unit tests. How do we make that change? Well, in the last episode, I showed you how to deploy CodeBuild, and the basis of this was two files: the CloudFormation template defining the CodeBuild project environment, and the CodeBuild build spec, which defined the actions that CodeBuild is to perform during each build execution. I mentioned that one of the benefits of separating out the build spec into a separate file was that we could make changes to our CodeBuild actions simply by changing the build spec file and committing it to source control. Well, that's precisely what we want to do here. We want CodeBuild to run a different npm script to perform its tests. And so we update the list of commands in the build spec file. Another nice thing here is that we can commit the CodeBuild change in the same GitHub commit as all the other files that we've changed. And CodeBuild will use the new configuration as part of our new changes. So here is the commit with our changes to our test configuration and our CodeBuild change. And if we push this commit, CodeBuild will run. And here's what we see in CodeBuild after we push the change. This is the actual log of the CodeBuild build. I'm showing you this because we can see that it's specifically now just running the unit test and that this test is successful. So one final step this episode. Having to manually find the API gateway hostname and set it to an environment variable is pretty clunky, and we can do better than that. We know the logical name of our API gateway, and so we can use the AWS SDK to look up the API's metadata as part of our test setup. So here's our integration test again, but I've added the setup code to look up the API's hostname. I'm going to go through this in some detail. So first of all, we create a setup function in our test. It is going to find the API endpoint value that we used to manually set via an environment variable. So to make this run before the test itself, I use Jest's before all function. So first, we need to know the name of our API gateway. And if we're using the default SAM deployment that we used back in episode 1, then the default name is sam-app. But otherwise, we can override that with an environment variable. For now, this default SAM app will be okay. And here's the main part of this. We're making a call to the AWS platform via the AWS JavaScript SDK. And we request a list of all the deployed API gateways in the account. Now, for bigger accounts, this might need paging, but for clarity, I'm just using a simple version here. Once we've got the response back from AWS, we can find the API gateway that we care about by looking at the list of all the APIs that we got back. And then once we've found that API gateway, we can grab the API endpoint value that AWS gives us. And so now to our test function. We no longer need to read anything from an environment variable, but we do check that the API endpoint has been properly located. And apart from that, our test is unchanged. Since we are now making calls to AWS directly from our test code, we need to make a couple of project configuration changes. First, we need to declare a dependency on the AWS SDK. And we also need to tell the AWS SDK that we want it to use the same configuration as the CLI, which we do by setting the AWS SDK load config environment variable before calling jest. Now, since we can make that change just here in the script target, we don't need to manually set it each time. So now we can run our integration test with no manual environment variables. See, we're running npm run integration test with no environment variable. We see that the setup code is looking for an API gateway named SAM app. And we can also see that it has successfully found the API endpoint for the gateway, and it uses that to run the test. So here's what we covered today. Here's a quick recap. First of all, I went over integration testing and why I think it's valuable to do integration testing against the application deployed to the cloud. I also added an integration test to our coffee store project. I modified the CodeBuild build spec via a GitHub commit just to run the unit tests for now. And then I introspected our deployed application in AWS to get the location of the API gateway. So this is a big step forward. We can now run automated integration tests against our application deployed to the cloud. However, there's still an assumption that the app will be deployed to a specific name, that sam-app thing that I had. And also, we're not running the integration tests as part of our CI validation. And so what I'm going to be doing next time is improving all of this, introducing isolated environments, allowing us to have different named environments and allowing us to bring that test into our continuous integration automation. Now, of course, the best way to know when that episode is available is to subscribe on YouTube. So please go and subscribe on YouTube, which you should be able to do right there. And in the meantime, here is this week's resources. As ever, please drop me a line if you have any questions or comments. And I will see you next time for episode 5.